Today we're going to learn how to determine a chemical formula when you are given a chemical name. We're going to be working with monatomic ions. These are ions that contain atoms of only a single element. You can accomplish this in 5 simple steps. Let's figure this out by doing some examples. These examples will get more complex as we move on. Our first example is sodium chloride. Step 1. Use the periodic table and your ion sheet to determine the symbols for each element. So use a periodic table, use the ion sheet, figure out what we're working with here. Sodium is the symbol Na, and chloride is Cl. Okay? Step 2. Use the periodic table and your ion sheet to determine the ionic charge of each element. So you can use common knowledge, you can use your ion sheet, you can also figure this out from the periodic table. Sodium is a group 1, that means that it has 1 electron in its outer shell that it will lose. Whenever it loses that negative electron, it's going to become positively charged, positive 1, because it just loses that 1 electron. You can use your ion sheet, look up chloride, it's the easiest way to do it, you'll find Cl minus 1. Okay? Step 3, you're going to use basic math to balance out the charges of everything you have here. Okay, so you're going to look at the charges on each of these things. So you have +1 on the sodium, -1 on the chloride. If you add those together, the +1 and the -1, that will balance out and give you 0. So this is going to be balanced out, and the reason why we do this is because we want to have a neutral final molecule. Okay? Step 4 is going to be to write these symbols together. Okay, so when you do that, you just write Na followed by Cl. You write them together this time. You squish them together. And step 5 is to count the ions that you had above. Okay, so if you have more than one of each, you're going to write that total as a subscript on each of these. Okay, so we only have 1 here of each. We just have the 1 sodium, we have the 1 chloride. So we do not have to write anything else. Our final answer here is going to be NaCl, which is the chemical formula for the chemical name sodium chloride. Okay, the secret word for this video is carbon. Okay, C-A-R-B-O-N, carbon. And we're going to move on to a couple other simple examples that I want you guys to be able to see. Okay, so the next one we're going to look at magnesium oxide. Okay, so remember, whenever we're working on these, we're going to follow those 5 steps. So step 1, use the periodic table, your ion sheet, to determine the symbols for each element. Okay, so magnesium is Mg, and oxide, we're going to be working with oxygen. Step 2, use those same things, use the periodic table and your ion sheet, and determine the ionic charge of each one. Remember, magnesium, look that up, that's in group 2, so that's going to be a +2 ion. If you use your ion sheet to find oxide on there, you will find that that is going to be an O with a -2 charge. Okay, step 3, use the math to balance the charges. On the magnesium, we have a +2. On oxygen, we have a -2. That balances out, so we don't have to do anything with that step. Remember, our goal is to get a neutral final molecule. Step 4, you're going to write these symbols together. So you're going to write Mg followed by the O. And step 5 is to count the ions, and if you have more than one of them, you'll have to have a subscript. We just have 1 magnesium, 1 oxygen, so our final answer is already done. It's MgO, which is the chemical formula for magnesium oxide. Okay, the third of the simple examples is going to be aluminum nitride. Okay, so step 1, use the periodic table and your ion sheet to determine the symbols. Okay, we know that aluminum is a L, and nitride is going to deal with nitrogen. Use your sheet. Step 2, use those same 2 devices and determine the ionic charge of each. Aluminum, periodic table, also on your sheet, has a charge of +3, and if you look up nitride, that is nitrogen with a charge of -3. Okay? Step 3, use basic math to balance the charges. We have a +3 and a -3, so we're already done there. Step 4, write these 2 symbols together. So we're going to write Al followed by an N. And step 5 is count the ions. If you have more than one, write a subscript. So we just have one aluminum, we just have one of the nitrides, so our final answer is already here for us. Aluminum nitride is ALN. Okay? Now we're going to go and kind of up the complexity here. So the next 3 examples we're going to look at are going to be a little bit more complex than these original ones. Okay, so we're going to start off with lithium oxide. Okay, so we have lithium oxide. Okay, so step 1, use the table, figure out the symbols. Lithium is Li. Oxide, you're going to use, it's an oxygen. Okay, use the periodic table on your sheet to determine the charge. If you look this up, you'll find out that lithium has a positive 1 charge, and oxygen, or oxide, in its oxide form has a negative 2 charge. Remember, use your ion sheet to figure this out. Okay, so you have lithium here with a positive 1 and oxide with a negative 2. Step 3, we're going to use math to balance the charges. Okay, so if you look on the left side here, you have lithium that just has a +1, oxygen has a -2. If you add that together, you don't get to 0. It doesn't balance out. And the reason why is because you'll be left with -1 because you have one more negative charge than you have positives. So what we're going to do here is we're going to give this equation another thing to work with. So we're going to add another lithium in here. So now, whenever you do the math, you have +1 and +1 for lithium, and you have -2 for oxygen or oxide. This is going to balance out. Okay, and the reason why, again, is we want our final molecule to be neutral. Okay, so we're going to go ahead and do step 4. We're going to write these symbols together. So we're going to write LiO, and then step 5, you're going to count the ions. If you have more than one, we're going to use the subscript. Okay, so we have 2 lithiums here, so we're going to put a 2 right below the lithium. As a subscript, we have 1 oxygen, so we don't have to write anything else there. So our final answer for this one is going to be Li2O, or 2 lithium, 1 oxygen. That's how you write out the formula for lithium oxide. Okay, I have 2 more examples for you here that are a little bit more complicated. As we go, we're going to get a little bit more complex. The next one we're going to look at is aluminum iodide. Okay, aluminum iodide. So step 1, figure out the symbols. Aluminum is Al, and iodide is iodine, which is I. Now look up on the ion sheet, use the periodic table to figure out the charges of these. And remember, just like before, aluminum is still going to be +3. And if you look up iodide on your sheet, you'll find out that that is I with a -1 charge. Okay, step 3, use the math to balance the charges. Aluminum is +3, iodide is -1. That does not balance out. So what we're going to do is we're going to add another iodide, I -1, +3. Now we have -2 on the right side. That still doesn't balance out. So we're going to add a third iodide, okay, or a third iodine with a -1 charge. Okay, now this balances out. Okay, so we can move on to step 4. We're going to write our symbols together, which is Al followed by an I. And step 5, we're going to count the ions. Okay, so we have 1 single aluminum, so we don't have to write anything there. Remember, if you have more than 1, you have to write a subscript on each. So we have 1, 2, 3 iodines over here. So we're going to write a 3 down below there. And our final answer is going to be Ali3, which is the chemical formula for aluminum iodide. Okay, the last one in these a little bit more complex examples is going to be calcium fluoride. Okay, calcium fluoride. Okay, we're going to start off, we're going to get our symbols. Okay, going to look that up and figure out this is a +2 charge, this is a -1 charge. Okay, this doesn't balance out, so we're going to have to give it another fluorine, -1. Now they do, +2, -2, that balances out. We're going to write them out. So CaF, just have 1 Ca, we don't have to do anything. We have 2 Fs over here, so we're going to put a little 2 after the F, and that is it. So CaF2 is calcium fluoride. Okay, the last part of this we're going to do is we're going to look at 2 examples that are just a little bit more complex than that, and then you'll have everything you need to get started working with these on your own. So the first one we're going to do here is we're going to do aluminum sulfide. Okay, so aluminum sulfide. So we're going to go through the same process here. Aluminum is Al, sulfide is sulfur, which is S. Going to look this up on the periodic table, use your sheet. Aluminum has a +3 charge. Sulfide ion has a -2 charge. Okay, so you're going to look at this at first and think, okay, we need to do step 3. We need to balance the charges, but we can't do that by working on one side or the other. Okay, so for this, we're going to have to work with both. So think of like an algebra whenever you have to factor and different things like that. It's kind of what we're going to be doing here. Okay, so you can think off the bat, all right, well, if you want to get to the same amount of charge in these whole numbers, let's start by adding an aluminum, okay? So let's put another aluminum +3. So now on this side over here, we're looking with a total of +6. Okay, so we can get that over here. Okay, we need to get this to -6 now. Okay, so let's add another S with a 2 minus. Okay, so now we're at -4, and we're going to add another S -2. There you go. Now we have +6 -6. That's going to balance out to be 0, which is exactly what we want. Okay, so we'll move on to step 4. We write the symbols together. So A, L, and then S, so aluminum and the sulfur. And then this is whenever you're going to start using multiple subscripts. So remember, we count. We have 1, 2 aluminums here, so we're going to write a little 2 right after the aluminum. We have 1, 2, 3 sulfurs, so that's going to be a little 3 after the sulfur. So this is where it isn't just always going to be one of your elements only has 1, so you don't have to write it. This time we have different numbers for both, so we have to write the subscripts after both. So Al2S3 is the chemical formula for aluminum sulfide. Okay? We're going to do one final example here. It's going to be tin 4 nitride. Okay, so the first thing we're going to do here is, again, look up the symbols. So tin is the symbol Sn, it's a little weird. Nitride is nitrogen, which is N. Okay, so tin 4, if you look that up on your sheet, you can figure that out by knowing that number. That means that it's a tin with a +4 charge. Nitride, look that up on your sheet. You'll figure out that that is a nitrogen with a -3 charge. Okay, so just like we did over here, we're going to have to balance them out by adding to both sides, because we can't just add one or the other, because that won't work out. So let's figure out here, okay, well, let's try to get to that 12 again, because 4 times 3 is 12, and 3 times 4 is 12, so let's see what we can work with here. Okay, so let's add another Sn, another tin, so +4. Okay, that gives us to 8. All right, let's do one more to get to 12. And then let's do over here the same thing to get to 12. Okay, so we have all of this is going to give us a total of a +12 charge. Let's try to get that over here. So let's put another N over here, -3, we're at 6. Let's do another N, -3, we're at 9. And -3, you add all that up, we're going to be at -12. Okay, so we have 12 on both sides. They are going to balance out and give us a neutral final molecule. Okay, so the next step is to write these out. So write out the symbols, Sn with a big N. Remember, this is a small n followed by a big N, because the small n is part of tin. The big N is nitrogen. Okay, and then you're going to count and write the subscripts below. So 1, 2, 3 tins, and 1, 2, 3, 4 nitrogens. Gives us our final answer of Sn3, N4. That's how you write out tin 4 nitride as a chemical formula. Okay, so if you zoom out here, you can see what all we did. We started out up here with just the simple ones where you just basically, it's already done for you. And then we went down to the second row where it got a little bit more complicated because you had to start balancing it out by adding to one side. And then finally in that last portion, you had to add to both sides to get to a higher number just to balance those charges. Okay, so remember here, there's 5 steps. So use the periodic table on your ion sheet, have both of those out when you're working on this to determine your symbols. Use those same 2 pieces of paper to determine your charge of each of your ions that you're working with here. Step 3, use the basic math and balance out the charges. Make sure that your final molecule is going to be neutral or get to 0 total charge when you add both sides together. Step 4, write out your symbols, and step 5 is count your ions that you used. If you have more than one, make sure that you write the total number of ions that you needed in order to balance it. as a subscript on the final chemical formula. Again, this is the process of going from a chemical name written out in words to a chemical formula written out in the ion symbols, the periodic table's symbols, basically letters. This goes from name to formula. And this is how you do that with monatomic ions.